The lifespans of gorillas in a particular zoo are normally distributed. Okay, that means that we can use the z-score tables. Okay, the average gorilla lives 20.8 years. Okay, the standard deviation is 3.1 years. Use the empirical rule to estimate what percentage of the population is aged between 17 and 27. So I don't have a calculator in front of me. Let's see. All right, like magic. So what we've got is we have to know where we are on the normal curve in order to use the empirical rule. So what we've got to do is we've got to figure out, in fact, draw a little diagram here. It's helpful. Right there in the middle is the 20.8, and if the standard deviation is 3.1 years going forward, that would be 23.9 going forward again. What is it? 3.1. That's 27. Okay, so we got 27 there. So it looks like we're 2 standard deviations away from the mean on the right side, and then we're going to go 17.7. Let's see if that takes us there. 20.8 minus 3.1, and that is 17.7. Okay. So what we're looking for is in between here, here, and here. So we've got these 3 right here. All right, now I know that one's 34, that one's 34, and this one is 13.5. So if I add those together, it's going to be 68 plus 13.5 is going to give us 81.5%. Okay, which makes sense. We're 64% here and that extra. All right, so that's just using the empirical rule. Okay, cool. We didn't need our tables for that. Now we're moving to 61. The average SAT score in the United States is 1060 with a standard deviation of 195. I do believe that's actually true. Assuming a normal distribution, which is what the SAT believes it is, use the empirical rule to estimate what percentage of high school students score below a 670 and between 670 and 865. I don't know why I said below. Well, let's see. All right, so 1060 is right here, and they said that 195 is the standard deviation, so we are at 1255 that way, so we're going to go the other way. So let's go, well, minus 195. Okay, there's 865, okay. So that's one standard deviation below, okay. Then I'm going to go 1060, no, I'm sorry, 865 minus 195 again. That'll take me to 670. So what they're asking for is what is this region right here? All right, now this is actually a typo. This should have been, there should have been an E that said 13.5% because that is what the empirical rule says. This area right here is 13.5. So the answer is E, the invisible E, 13.5. All right, let's see if there are any other typos. A study found that the number of hours each person slept was distributed normally. Okay, that's actually important in order to use these tables. If we need them, we'll see. Nope, not for that. So the study found that the average person slept 8.2 hours with a standard deviation of 0.7 hours per night. How much sleep would you need to be in the top 2.5%? Okay, so you would have to be, to get the 2.5%, if you remember, this is the 50, okay, that's 34 here, 13, and then that right there is 2.5%. So you are, that is a z-score of 2. So you are 2 standard deviations away from the average. So what we'll do then is we will add 8.2, we're going to add 0.7, and then we're going to add 0.7 again, and then that'll take us to the second standard deviation, and we know that that represents the top 2.5%. All right, have a good day, everybody. Or not. Kids, man. All right, 9.6. So that means if you had 9.6%, you sleep more than 97.5% of everybody else. All right? All right, last one. According to the study in 62, use these scores to estimate what percentage got less than 6.5 hours of sleep. Okay, so now what we're doing here is we're really zooming in on what, I need to know how many standard deviations away that is exactly, okay? 6.5 is not, I believe, going to fit very cleanly. So what you got to do is you have to take the formula is this. You take the z-score equals how far are you away from the mean, okay? So you take your data point of interest, you subtract how far you are from the mean, and then you divide by the standard deviation, and that will tell you where you are in the normal curve. Okay, so you need that little formula. So in this case, I've got 6.5, and I need to minus the 8.2 that is the mean of the average, it's the average number of hours that people sleep. And then I got to divide by the standard deviation, which we were given 0.7, and we have to know that. Somebody had to calculate that for us in order for us to do this. Okay, if you don't know the standard deviation, then you don't know how your data is spread. All your data can be clumped towards the middle or spread out. You don't know your z-score. Okay, so you need the standard deviation. So we'll let me show you what I'm doing in the calculator. All right, let's see if I can modify this. Okay, so I get that. All right, so that's the distance from it. I'm on the negative side. Then I'm going to divide by 0.7, and that tells me how many standard deviations. So I'm way to the left. Okay, way to the left. So this means then that I'm going to have very small percentages. Okay, so what I'm going to do is I'm going to see that my z-score is negative 2.43, and let me minimize that. That means the video is ready. And I got to look that up. Okay, and this is less than, so my table is built for the left-hand side, so that's great. I don't have to subtract from 100. So negative 2.43. So I'm on the negative side, negative 2.4, and then I'm going to move over to negative 2.43. All right, 0.00755. 0.00755. So that's basically the best guess that I got, because let me just double check that. Negative 2.43. 0.00755. Okay, so I don't know why it's a 0.78, but that's pretty much as close as we can get. So it's a very small percentage. Okay, so